Hello, everybody. Am I audible? Am I audible? Chikkodi students, can you tell me whether I'm audible or not? Chikkodi?
Audible, ma'am.
Yes. Okay, thank you. Rani Bennur, am I audible? Rani Bennur, am I audible? Girls? Girls, you have to tell me whether I'm audible or not. Rani Bennur girls. You are not audible, Rani Bennur. Check your mic. Rani Bennur student. On illa ಅನ್ಸುತ್ತೆ. On ಮಾಡಿ. Okay, fine. I got to know that I am audible. No, not audible, Rani Bennur. Okay, so assuming that I'm audible everywhere, I'll be beginning with this session. So today we'll be starting with the new chapter biomolecules, but before that we have a very small concept remaining in chemical kinetics. We were discussing chemical kinetics, right, in the previous session. I remember that we discussed about activation energy,
Rani
order,
is audible.
and T half, everything. Yes? Anybody wants to speak? So everything. So last part, that collision theory, I have some 2 to 3 questions based on that. First we'll finish off that, then we'll go to biomolecules. Okay. So we'll begin with, okay, just to revise how much you remember the chemical kinetics part. I'm going to begin my session with this question. Okay, how much you remember chemical kinetics? So let us see. Find out the order of the reaction from the given 3 statements. Find out the order of the reaction from the given statement. First two part is quite easy. Only you may find tricky in the last statement to find out the order using last statement. No, it doesn't take much time. Very simple. How do you do this? Can I get your poll result? So solve this and give me your poll result. Chikkodi, I think you have Q card. Rane Benu students doesn't. So Chikkodi students, you can give me your answer using that Q card. How do you do this? Either and ಮಾಡಿದೀವಿ ನಾವು, already we have discussed this kind of question. You have to find out the order with respect to each species, with respect to A, with respect to B, with respect to C. Then you will get the total order of a reaction. So they have given a reaction. In first statement they are telling if concentration of A is doubled, keeping concentration of B and C constant, the rate of a reaction doubles. So ಇದು ನಮಗೆ ಏನು ಹೇಳುತ್ತೆ, if you double the A, the rate also gets doubled ಅಂತ ಅಂದ್ರೆ we have discussed few examples, so by now we should remember that when the rate is doubling with the increasing or doubling the concentration of a particular reactant, so it is the rate is directly proportional to first power of concentration of A. That means it is first order with respect to A. ಆಯ್ತಾ? Next, second statement ಅಲ್ಲಿ B is half, keeping concentration of A and C constant, the rate of a reaction remains unaffected. That means whatever you do with B, the rate is not getting affected andre, the rate is independent of B. So that means rate, it is zero order with respect to B. If it is not getting affected, that means it is zero order with respect to B. Alva? Next, if a concentration of C is made 1.5 times, the rate of a reaction becomes 2.25 times. Now, how do we do this? So, I have discussed one similar question. Yen madi, you do one thing. Let's say, earlier, R1 anta ತಗೊಂಡ್ಬಿಡ್ತೀನಿ. So let us write this rate equation, okay? So earlier rate is equal to K into C power X. I don't know the order with respect to X. I have taken like this. Now, when I increase the concentration of C by 1.5 times, what is happening to rate? It is multiplied by 2.25. Alva? So that means now it is becoming 2.25 that of the initial rate into ಯಾವಾಗ ಆಗ್ತಾ ಇದೆ, when this is multiplied by 5, sorry 1.5 ಅಲ್ವಾ? ಇದು ನೀವೇನಂತ ಬರೀತೀರಿ ಇವಾಗ, k into 1.5 to the power x into c to the power x. Okay, ಇಲ್ಲಿ 2.25 R1, it is as it is. Now what we'll do, we'll take the ratio of these two, ಆಯ್ತಾ? Let us take this as 2, let us take this as 1. Let us take 2 by 1. ಏನಾಗುತ್ತೆ ಅವಾಗ? 2 was 2.25 R1 by R1 is equal to, ನೋಡಿ ನಾ ಇದ್ರದ್ದು ರೇಷಿಯೋ ತಗೊತಾ ಇದ್ದೀನಿ, these two ratio I am taking, k into 1.5x c power x k. So R1 cancel, k cancel, c power x cancel. We have 2.25 is equal to 1.5 to the power x. Now 2.25 you can write this as 1.5 whole square. Okay, this is nothing but 1.5 whole square equate to 1.5 x. So you have to find out, look, when we arrive at this part, so can I write this in terms of 1.5 power? Because in the right hand side we have 1.5 base. Alva? So there should be some way to find out order. So take this as 1.5 whole square. So that is nothing but 2.25. Now when base is same, then you can equate these two, alva? So now we get to know x is equal to 2. That means from this statement we get to know rate is equal to k to the power k into c to the power 2. Alva? Here from all the three statement ನಮಗೆ ಏನು ಗೊತ್ತಾಯಿತು? It is first order with respect to A. It is zero order with respect to B. And it is second order with respect to C. Now order, total order of a reaction ಹೇಗೆ? Sum of the power ಅಲ್ವಾ? ಏನು ತಗೊಂತೀರಾ? 2 plus 0 plus 1 ಏನಾಯಿತು? 3. So option C. ಹೀಗೆ ಮಾಡಬೇಕು ಆಯಿತಾ. ಇದು ತುಂಬ ಕಾಮನ್ ಆ್ಯಂಡ್ ಡಬಲ್ ಆಗೋದು ತುಂಬ ಕಾಮನ್. ಈ ರೀತಿ ಅನಲೈಸ್ ಮಾಡಬೇಕು. ಆಪ್ಷನ್ ಸಿ ಈಸ್ ಕರೆಕ್ಟ್. ನಾವು can you try this? We discussed this expression in the previous session last whenever we discussed kinetics.
D.
Can I get your poll result, Chikkodi students? This is easy, no mathematics involved, nothing, no solving.
Option D.
Option D.
D, fourth one. Okay. How do you do this? K.
Option D.
Okay. ಹೀಗಿದೆ ಅಲ್ವಾ? ಏನು ಮಾಡೋಣ? We'll take this whole thing to the denominator so that this becomes positive. You know, just for your clarity, I have written like this. Now they're asking which factor should register a decrease for the reaction to proceed more rapidly. More rapidly ಅಂದರೆ ನಮಗೆ ರೇಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು ಅಲ್ವಾ? ದಟ್ ಮೀನ್ಸ್ ಐ ಕ್ಯಾನ್ ಸೇ ಸಮ್ಹೌ ಇನ್ ಸಮ್ ವೇ ಐ ಕ್ಯಾನ್ ಸೇ ದಿಸ್ ಶುಡ್ ಇನ್ಕ್ರೀಸ್ ಅಲ್ವಾ? ಇದು ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕು ಅಂದರೆ ಏನಾಗಬೇಕು? ದಿಸ್ ಡಿನಾಮಿನೇಟರ್ ಶುಡ್ ಡಿಕ್ರೀಸ್ ಅಲ್ವಾ? ಇದು ಡಿಕ್ರೀಸ್ ಆಗಬೇಕು. ಇವಾಗ ಇದು ಡಿಕ್ರೀಸ್ ಆಗಬೇಕು ಅಂದರೆ ಏನಾಗಬೇಕು? ದಿಸ್ ಪವರ್ ಶುಡ್ ಡಿಕ್ರೀಸ್ ಅಲ್ವಾ? ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಶುಡ್ ಡಿಕ್ರೀಸ್. ಸೊ ದಟ್ ಈಸ್ ವೈ ಆಪ್ಷನ್ ಡಿ. ಗುಡ್. ನಾವು can you answer this? Rate of a reaction after 20 minutes. They have given you T half and the initial concentration. How do you do this? Not very, very difficult, I would say. If you try to write and analyze the question properly, so the initial concentration is 12 molar, right? Now they have given us the half-life period of a first order. First of all, we got to know it is first order reaction, which is very important, okay? So some words you should note down. This is first order. And here, T half they have given. T half andre the time required to get into half of the initial concentration, alva? So half of 12 andre enaitu 6 molar aitu. So 12 to 6 molar barlikke the time required, the T half time required was 10 minutes. And we know that for a first order reaction, the T half value is going to be constant. It doesn't change. Iga, na next 6 molar to half of the 6 molar ಏನಾಗುತ್ತೆ 3 molar. Next half reduction ಗೆ the time required is again going to be same, that is 10 minutes. Alva, 12 to 6 half reduce ಆಗಕ್ಕೆ it was 10 minutes. Since it is first order reaction, the T half is going to be constant. Now again 6 molar to 3 molar reduce ಆಗಕ್ಕೆ, half reduce ಆಗಕ್ಕೆ, it is again going to be 10 minutes. Now 10 plus 10 total ಎಷ್ಟು ಟೈಮ್ ಆಗಿದೆ 12 to 3 molar ಬರಲಿಕ್ಕೆ 20 minutes ಅಲ್ವಾ. 12 to 3 molar ಬರಲಿಕ್ಕೆ ಕಂಪ್ಲೀಟ್ ನಮಗೆ ಎಷ್ಟು ಬೇಕಾಗ್ತದೆ, ಇಟ್ ಇಸ್ 20 minutes. ಈಗ ಅವ್ರು ನಮಗೆ ಕೇಳ್ತಾ ಇರೋದೇನು, ವಾಟ್ ಆರ್ ದೇ ಆ್ಯಕ್ಚುಲಿ ಆಸ್ಕಿಂಗ್ ಅಸ್? ಸ್ಟಾರ್ಟಿಂಗ್ ವಿತ್ ದಿ ಇನಿಷಿಯಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ 12 molar, ದ ರೇಟ್ ಆಫ್ಟರ್ 20 minutes. ರೇಟ್ ಆಫ್ಟರ್ 20 minutes. ಈಗ if I have to write the rate expression, how do I write? Rate is equal to rate constant K into the reactant concentration to the power 1. Alva? Because it is first order to the power 1. Now we have to find out rate. We know this concentration now. 20 minutes yellinda yellig bandade. Initial it was 12. After 20 minutes it has reached 3. Right? We know this. This is 3. But we don't know K. But we can find out K. How do we find out K? Look, they have given us T half alva, and they have told us it is first order reaction. What is the expression for T half? 0.693 by K. We have to find out K. K will be equal to 0.693 by T half. Alva? 0.693 by T half value ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ 10. 0.693 by 10 ಏನು 0.0693. So 0.0693 is the value of K we found out using the T half expression. So put that value over here. So ಏನಾಗುತ್ತೆ, rate is equal to 0.0693 into 3 molar per minute. ಯಾಕೆ per minute? This will be in per minute ಅಲ್ವಾ. K will be in per minute. ಇದು T half minute ಅಲ್ಲಿ ಇರುತ್ತೆ. ಸೊ ಟೋಟಲ್ ಏನಾಗುತ್ತೆ ಪರ್ ಮಿನಿಟ್ ಇರುತ್ತೆ. ಏನಾಗುತ್ತೆ ಆಪ್ಷನ್ ಡಿ. ಆಪ್ಷನ್ ಡಿ ಅಲ್ವಾ. ದಿಸ್ ಇಸ್ ಅ ವೆರಿ ವೆರಿ ಗುಡ್ ಕ್ವೆಶನ್. ಇಟ್ ಇಸ್ ಅ PYQ. ಅಬ್ಸರ್ವ್, ಇಟ್ ಇಸ್ ಅ PYQ. ನಿಮಗೆ ಒಂದು ಬೇಸಿಕ್ ಯಾವಾಗಲೂ ನೆನಪಾಗಬೇಕು, T half is going to remain constant. ಸೊ ಇಲ್ಲಿ ಇನಿಷಿಯಲ್ ಕೊಟ್ಟಾಗ ನಾನು T half ಇಂದ ಹೇಗೆ ಡಿರೈವ್ ಮಾಡಲಿ ಫೈನಲ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ಟರ್ 20 minutes. ಇದು ಐಡಿಯಾ ಬಂದರೆ ದೀಸ್ ಆ್ಯಂಡ್ ಆಲ್ ಯು ವಿಲ್ ಡೂ because you know the formula. But ಈ ಐಡಿಯಾ ನಿಮಗೆ ಬರಬೇಕು. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಫೈಂಡ್ ಔಟ್. ಆಪ್ಷನ್ ಡಿ ಇಸ್ ಕರೆಕ್ಟ್. ನೆಕ್ಸ್ಟ್ slope of the plot of log K versus 1 by T they have given, and they're asking you to find out activation energy in joule per mole. This also is not a very difficult if you know the formula. Yes, maybe calculation part will take time, might take time, but reaching there would not be very difficult. So you know this formula, right? When you apply log, you end up getting this. right? So this is in the form of y is equal to mx plus c, where m is the slope. Alva, you may know this. So this is y log k, and x is 1 by t. C is log a, which is the intercept, and m is this value. Okay, m, the slope m will be this value, which is minus ea by 2.303 r. Aita? Now the slope value they have given, remember this will be negative value, minus 0.564 is equal to ea by 2.303 r. Okay, 2.303 r. Now what are they asking us to find out? They're asking us to find out activation energy. That means this is ea, alva. So we'll cross multiply, minus minus hogatte, this minus they get cancelled out. So ea is equal to 5.64 into 2.303, and what is the value of r? 8.314. Can you calculate this? Calculate this and tell me. ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಇದನ್ನು. ಅದೇ ಹೇಳಿದೆ, if you find out the formula, it is not very difficult. Only the calculation part might take time. ಅದು ಬಿಟ್ಟೆ ಈ question ಅಲ್ಲಿ you should not invest much time. Yes, how much you are getting, can you tell me? Solve this and tell me.
Option A.
Option A, you will not exactly get 108, right? When I solved, you will get 107.9 something, right? So
Round
you
off.
can approximate this to 108. Yes, option A is correct. Okay, this is how you do. A graph also you have in your NCRT. So that's why I have taken this question. Next, this question. Which is correct, which is wrong? This is one different kind of question in this thing. Nodi, try ಮಾಡಿ. Can I get your
Option D
cue
for
card result, Chikkodi students? Option D? Okay. Okay. B.
Option D for
Quickly,
John.
everybody Chikkodi students. Okay, thank you. Yes. Everybody, every Chikkodi students, give me your cue card result. You have, you're simply sitting, many of you. Okay. So many different answers I'm getting. So first few of you might think that when we have an option all are true, then there is more possibility of it becoming option D. And if you're thinking in that way, yes, it is true. Option D is correct. But let us understand why. This is a very good question. Now, first of all, they're saying threshold energy of the reaction is. Now, one thing you understand, if they give you any value with this kind of graph, you have to remember one thing. This part you have from here to here, this entire thing, this is called as this entire region or this entire energy, that is threshold energy. Threshold energy. What do you find over here? At this point, you will find activated complex. Okay, this is where you find activated complex. This 0 to 100, this is threshold energy. That means the first statement is correct. Threshold energy of the reaction is 100 kilojoules, that is correct. Now, this part from 40 to this ಈ ಕರ್ವ್ ಏನಿದೆ ಅಲ್ಲ, ಈ ಕರ್ವ್, ಈ ಎನರ್ಜಿ ಏನಿದೆ ಅಲ್ಲ, ದಿಸ್ ಇಸ್ ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ ಫಾರ್ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್. EA forward anta kodtare. Okay, and this part of the curve, this is activation energy for reverse reaction or backward reaction. And this part, ee point ideyalla 40 kilojoules, A plus BC, idenidu A plus BC is at 40. That means A plus BC it what? It is reactant. This is energy of reactants. Okay, and this point is energy of products. Okay, energy of product. Now first statement we got to know. Now this is EF is 60 kilojoules andre artha enu? EF means activation energy for forward reaction. What did I tell you? Activation energy of forward reaction is this part, this entire part. Illi enide nodi, 100, 40 alli the reactant was there. Now if the reactant should get converted into product, it should reach this threshold energy. How much more energy is required to reach this stage? ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀರಾ? 100 minus 40 is equal to 60. That means when the reactants are at 40 kilojoules, if they get extra 60 kilojoules, they can reach this threshold energy. That is the activation energy required for this forward reaction. Okay, 60 kilojoules energy, that is correct. While ER, it is nothing but reverse, energy of the reactant. ER is energy of the reactant. Correct alva? It is energy of the reactants estide 40 kilojoules ide, that is also correct. This is correct, this is correct. Now delta H is 20 kilojoule. Delta H anta andre enu? Delta H means energy released or absorbed during the reaction. How do you find out delta H? Energy of product minus energy of reactant. Product in estide 60, reactant 40, ಎಷ್ಟು ಬರುತ್ತೆ? Plus 20 kilojoule. So this delta is correct, delta H is correct, and since delta H is positive, idrinda ನೀವು ಹೋಸತಿ in thermodynamics you have studied that this, right? Enthalpy, if it is positive, it is endothermic reaction. This is endothermic reaction. So that is the reason why option D is correct. All these three statements are correct. Okay, so if you have general idea in this kind of graph, what is this part, what is this part, you can answer any kind of this question. Aita ee tara graph kottidre, so option D is the correct one. Next, this one. Can anybody answer this? Direct question this is. colliding molecule must have what? There are two very important factors, right, for any collision to yield into product. First of all, the colliding molecule should have kinetic energy sufficient kinetic energy, and along with that they should collide with proper orientation. Simple question, you should not fail to answer. Option B is correct. Sufficient kinetic energy with proper orientation, if the colliding molecules have, they will yield into product. Yes, last question of this chapter. Reaction rate is
Option C.
given by option C, B, A correct ಗೊತ್ತಾಗಿಲ್ಲ. Reaction rate means, remember, it should yield into product. More product at a particular instead of time if you're getting, then the rate is high. When do you see the increase in rate? So just collision is not useful. The collision in naditide, that collision should be effective. Effective andre, the colliding molecules should come in a proper orientation and collide, and it should have sufficient kinetic energy. Only the effective collision will lead to product, not all the collisions, alva. So option C is the correct answer. Yes, so with this we'll wind up this chemical kinetics part. Now we are going to start with the last chapter, that is biomolecules. Aita, ಈ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ ಯು ಹ್ಯಾವ್ 4 ಡಿಫ್ರೆಂಟ್ ಪಾರ್ಟ್ಸ್, ರೈಟ್? ಯಾವುದ್ಯಾವುದು 4 or 5? ಸೊ ಕಾರ್ಬೋಹೈಡ್ರೇಟ್ಸ್, ಪ್ರೋಟೀನ್ಸ್, ವೈಟಮಿನ್ಸ್, and then nucleic acids, last is hormones. Of all these, carbohydrates and proteins are very important. Okay, so let's say if you don't like biomolecules chapter, you don't want to study anta andru, no, at least I want you to study carbohydrates and proteins part. Okay, don't leave that. So we'll begin with biomolecules. So if I give you synopsis, the answer, all the answers will be in the synopsis itself. I'll not get to know how much you know, right? So I'm not going to give you synopsis. We'll directly start with the question. There only we shall discuss the concepts. Aita? So beginning with the first question, yes. Monosaccharides, biomolecules, carbohydrates we are beginning with. Saccharides, we have
Option
mono,
C. C.
oligo.
Option C.
Option
C.
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 C ಹೇಳ್ತಿದ್ದೀರಾ? ಹಾ. So I expect very quick answer for this chapter because it is all fact based. No solving, nothing. Option C I've got from 2 students. What about others? Any different answer? And can I get your poll result for this? This is a very simple question. Monosaccharide means they will not break into further units, alva. Disaccharide, trisaccharide, they come under oligosaccharide. That means when you hydrolyze, they will break into 2 or more units. And polysaccharide means when you hydrolyze, they will break into many units. So that is polysaccharide. Now maltose is a disaccharide, sucrose is a disaccharide, lactose is also disaccharide. We know glucose is a monosaccharide, alva? And ribose is also monosaccharide. You have seen the structure of ribose, right? In nucleic acid part alli ribose ನೀವು ಈ ತರ ಫ್ಯೂರನೋಸ್ ರಿಂಗ್ ಬರ್ದಿದ್ದೀರಾ. So it is a monosaccharide. Option C is correct. Yes, this one. Match.
Option D. Fourth one.
Fourth one, okay.
Option D.
Yes. So Aldohexose means 6 carbon atom with aldehyde. Alva? Glucose we know it is aldohexose, 6 carbon atom with aldehyde. Fructose is ketose, right? It has ketone functional group. So it has 6 carbon with ketone functional group. Ribose ಇಲ್ಲೇ ನೋಡಿದ್ವಿ 1 2 3 4 and ನಿಮಗೆ ಇಲ್ಲಿ CH2OH ಒಂದು ಬರುತ್ತಲ್ವಾ, so that means 5. So it is aldopentose. Aldopentose. Next, erythrose, if you take, erythrose will be like this. If you don't know the structure, you can note down the structure. Erythrose is this. Okay, this is the structure of erythrose. Clearly it is aldehyde. And how many carbon atom? 1 2 3 4, totally 4 carbon atom. So that is why it is aldotetrose. D should be matched with 3, and we have that in only one option. Easy. Option D. Okay. This one.
Option A.
Option A.
Option A. Direct, right? Another direct question. So there are 5 reactions which will say or which will help us to detect the structure of glucose. This is one of the reaction, alva. When you treat glucose with phosphorus, you will get N-hexane. Actually, what does this tell us about glucose when you get this product? ಏನು ಗೊತ್ತಾಗುತ್ತೆ N-hexane ಬಂತು ಅಂದ ತಕ್ಷಣ? What do you actually identify when you get N-hexane? What do you get to know about glucose? Glucose is getting reduced to N-hexane. N-hexane means we have 6 carbon atom in straight chain, right? So we get to know that in glucose, all the 6 carbon atom are in a straight chain when we do this reaction. Option A is correct. Okay. Next, bromine water, glucose.
Option B, second one.
Second one. Okay. Others? Chikkodi students, can I get your poll result? These are very simple questions. Why are you not answering? Poll result. Everybody. Direct question, biomolecule is such a simple and small chapter. Yes, glucose, when you treat with bromine water, it is a mild oxidizing agent, right? So, I will not write the entire structure, but when you take glucose and when you add bromine water, so this will get oxidized to COOH, right? The same thing. This is called what? Gluconic acid. If both the aldehyde and alcohol, if both would have get oxidized andre, adikkenanta heltide, that product would be called as saccharic acid. Alva? Saccharic acid alli enagtittu, all, I mean, the aldehydic group and also primary alcoholic group would have get oxidized into carboxylic acid. So for this, only gluconic acid is possible. Option B is correct. Yes, coming to this. Tollens reagent, it will react and it will give derivative of what?
Option C.
Option C, ketone. Look, Tollens reagent and Fehling solution is not something that you are studying in this chapter. It is something that you already studied in aldehyde ketone chapter. Now in aldehyde ketone chapter, what did we discuss? If in aldehyde ketone, not like, we cannot compare that with this chapter, but one thing is common. When you treat any aldehyde with Tollens reagent, it will give Tollens test, alva? Now simple organic compound which is a ketonic compound, and when you treat that with Tollens reagent you will not get test. But any simple organic compound which is aldehydic, that will react with Tollens reagent, and this it will get converted into something like this. Plus you will get that silver precipitate, alva? That's why you get that silver mirror. Now aldehyde actually ಏನಾಯ್ತು, it gets oxidized to what? Sodium salt of carboxylate. ಇದಕ್ಕೆ ನಾನು ವಾಟರ್ ಅಥವಾ H ಪ್ಲಸ್ ಆ್ಯಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? RCOOH. ಏನದು? This is carboxylic acid, monocarboxylic acid. So glucose also contain aldehyde. So aldehydic part of glucose will react with Tollens reagent and it will get converted into carboxylic acid, one carboxylic acid. So Tollens ಜೊತೆಗೆ ನೀವೇನಂತ ಹೇಳ್ತೀರಾ? Reducing non-reducing sugar ಅಂತ ಕಲ್ತಿದ್ದೀರಾ ಅಲ್ವಾ ಬಯೋಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಲ್ಲಿ? You say this glucose and fructose, they are reducing sugar because they reduce Tollens and Fehling solution. If glucose is reducing Tollens reagent, itself it will get oxidized, alva? Aldehydic part of glucose, it should get oxidized to carboxylic acid, ketone agalla, carboxylic acid. So that is why option 3 A is correct. ನೆನಪಿರಲಿ, ಇದು ಬೇಸಿಕ್ಸ್ ಆಫ್ ಆಲ್ಡಿಹೈಡ್, ಇದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡ್ತಿದ್ದಾರೆ ಆಯ್ತಾ? ಎಸ್, ದಿಸ್ ಕ್ವೆಶನ್. ಆಪ್ಟಿಕಲ್ ಐಸೋಮರ್ಸ್ ಗ್ಲೂಕೋಸ್. How do you find out? Optical activity is the concept related to chiral center, alva? If you write the structure of glucose, this is how the glucose is. Now to find, I mean, for any compound to have optical isomer, it should have chiral carbon, alva? We'll find out whether this has chiral carbon or not. Illi C is double bonded to oxygen, andre it is like two similar bond with oxygen, not possible. Observe this carbon. This carbon is attached to hydrogen on one side, OH on other side, CHO on one side, and this entire group on the other side. So this carbon is bonded to 4 different groups. That is why this is chiral carbon. Coming to this, il nodi illi, this also hydrogen, OH, and this entire group is different, this entire group is different. So it is also bonded to 4 different groups, it is also chiral center. This also, if you see this 2 different group, OHH 2 different group. So all the 4 groups are different. This is also chiral. Similarly, this is also chiral. But this is not chiral because this carbon is bonded to 2 hydrogen. Same atom, if it is bonded, it will not be chiral. Similarly, C double bond O iradrinda, it is not chiral. So total number of chiral carbons is there 4. Now how do you find out number of optical isomer? 2 power n, where n is the number of chiral carbon. Estaಗುತ್ತೆ 2 power how many chiral carbon? 4. ಎಷ್ಟು 2 power 4? 16, alva? Do we have? Yes. Option C. Option C is the correct answer. Next. Can you answer this? Pyranose ring. How many carbon atoms? The cyclic form
Option
of
B. Option
glucose.
B.
D,
Option B. Two. Second one.
B. Okay, okay. Others? Cyclic form, right? The cyclic structure of glucose when you hemiacetal, Haworth structure. Haworth structure, this is how you write. ಈ Haworth structural ನೋಡಿ, this is a cyclic ring. And this is a 6 atom ring, but in that 6 atom, one of the atom is oxygen, not carbon. So this is carbon. One, ಇದನ್ನ ಈ ತರ ಬರೆದ್ರೆ it may look like an oxygen. Okay, let me write this properly. 1, 2, 3, 4, 5 ಅಲ್ವಾ? ಸೊ ಟೋಟಲ್ ಇನ್ ದ ರಿಂಗ್ 5 ಕಾರ್ಬನ್ ಆಟಮ್ ಇದೆ. ಸೊ ನೀವು ಈ ಥರ ಇಲ್ಲಿ ಬರೆದಾಗ ಯು ವುಡ್ ರೈಟ್ ಸಮ್ CH2OH. ದಿಸ್ ಇಸ್ ನಾಟ್ ಅ ಪಾರ್ಟ್ ಆಫ್ ಅ ರಿಂಗ್ ಅಲ್ವಾ? ದಿಸ್ ಕಾರ್ಬನ್ ಇಸ್ ನಾಟ್ ಅ ಪಾರ್ಟ್ ಆಫ್ ಅ ರಿಂಗ್. ಪಾರ್ಟ್ ಆಫ್ ಅ ರಿಂಗ್ ಕಾರ್ಬನ್ ಎಷ್ಟಿದೆ? 5 ಇದೆ, ರೈಟ್? ಸೊ ದಟ್ ಇಸ್ ವೈ ಆಪ್ಷನ್ ಬಿ ಇಸ್ ಕರೆಕ್ಟ್. ಎಸ್, ಫ್ರಕ್ಟೋಸ್ ಕಂಟೈನ್ಸ್ fructose.
Option D. Fourth one.
You should remember this structure. Option D, fourth one. Okay.
Option D, ma'am.
All glucose. D na? Okay, no. I'll just write down the structure. CH2OH. It is a ketose, alva. This is the structure of fructose. One ketonic group, correct. 2 primary and 3 secondary alcoholic group. This is primary alcohol. This is also primary alcohol. 2 idya. And this. Idu moor enaitu secondary alcoholic group aitu. So this is also correct. And 5 hydroxyl group. Hydroxyl group andre OH alva. 1, 2, 3, 4, 5. So that means all these are correct. Option D. Very good, very good. Option D is correct. Chiral centers ಎಷ್ಟಿದೆ ಅಂತ. Glucose, you know, just now we saw. Fructose, you just find out.
Option B. Second one.
Option A. Okay. Glucose is 4. We saw alva
Option
in the
B.
previous to
Second
previous
one.
question.
Second one.
Second one, second one. Good, good. If you're going with second one, you're correct. Glucose, we know it has to be 4. So C ಮತ್ತೆ D eliminated. Fructose ಎಷ್ಟಿದೆ? I'll take this question. Here I have written the structure. Nodi, this is chiral. This is C double bond O. This 2 hydrogen not possible. This also 2 hydrogen not possible. So this is 1 chiral. This is 1 chiral. This is 1 chiral. Totally ಎಷ್ಟಿದೆ? 3 chiral center ಇದೆ. That is why ಆಪ್ಷನ್ ಬಿ ಇಸ್ ಕರೆಕ್ಟ್. 4,3 ಕೈರಾಲ್ ಸೆಂಟರ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. 4,3 ಇರುತ್ತೆ ಅಂತ. ಹಾ, ನೆಕ್ಸ್ಟ್. ಇನ್ಕರೆಕ್ಟ್, ನಾಟ್ ಕರೆಕ್ಟ್ ಅಬೌಟ್ ಫ್ರಕ್ಟೋಸ್.
Option C.
Option B, okay.
Option C.
So it is a ketohexose. That is so correct, alva. Ketohexose, we saw that in a first or second question only. This is correct. Now cyclic 5-membered structure of fructose is called as furanose. That is also correct. Glucosally we take pyranose. Fructosally we take ಫ್ಯೂರನೋಸ್ ಲೈಕ್ ದಿಸ್ ಅಲ್ವಾ. ಫ್ರಕ್ಟೋಸಲ್ಲಿ ಈ ರೀತಿ ರಿಂಗ್ ತಗೊತೀವಿ. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಕರೆಕ್ಟ್. ಫ್ರಕ್ಟೋಸ್ ಬಿಲಾಂಗ್ಸ್ ಟು ಎಲ್ ಸೀರೀಸ್. ದಿಸ್ ಇಸ್ ರಾಂಗ್. All the carbohydrate which you are studying, it belongs to D series, capital D. ಆಯ್ತಾ. ಎಲ್ ಯಾವುದಾಗತ್ತೆ? ಎಲ್ ಇಸ್ ಫಾರ್ ದಿಸ್ ಒನ್ ಅಮೈನೋ ಆಸಿಡ್. Okay, so it D series. This is the incorrect statement. And fructose is levorotatory compound. That is also correct. Okay, option C. ಇದರಲ್ಲಿ ಏನು ಇಲ್ಲ, ಎಲ್ಲ fact. It is the incorrect. D. All the carbohydrates, remember, it is D series. Next, we are coming to disaccharide. Maltose is made up of.
Option A.
Maltose.
Option A.
Option A. A. Okay, others. Ranebennu students, Chikkodi, other students, girls.
A.
A. Maltose is made up of alpha D glucose, only alpha D glucose. What about lactose? Can you tell me? Lactose ಅಲ್ಲಿ ಯಾರು ಇರ್ತಾರೆ? ಬೀಟಾ ಡಿ ಗ್ಲೂಕೋಸ್ ಪ್ಲಸ್ ಬೀಟಾ ಡಿ ಗ್ಯಾಲಕ್ಟೋಸ್. ರೈಟ್. ಇನ್ಯಾರಿದ್ದಾರೆ? ಸುಕ್ರೋಸ್. ಸುಕ್ರೋಸ್ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಆಲ್ಫಾ ಗ್ಲೂಕೋಸ್ ಬೀಟಾ ಫ್ರಕ್ಟೋಸ್ ಅಲ್ವಾ. ಇದಿಷ್ಟು ನೆನಪಿರಬೇಕು. So option A is correct, alpha D glucose. Next, invert sugar. Who is called invert sugar? Invert sugar, common name for one of the sugar. Very important point this is.
Option B, fourth one.
Option? You're not audible properly. Somebody
Fourth
is
one.
answering alla. Fourth one ಹೇಳ್ತಿದ್ದೀರಾ? Okay. No, you're wrong. It is not fourth one. Remember, it is sucrose. ಈ point ಮರಿಬೇಡಿ. Very, very important this question. Okay? Sucrose, it is called as invert sugar. Option A. So I have one more question, a similar question, which is related to this concept. That is a PYQ. ನೋಡಿ, this one. Why sucrose is called as invert sugar? That is due to this. Sucrose is dextrorotatory, but after hydrolysis, when you hydrolyze sucrose, ನಿಮಗೆ ಏನು ಕಾಣುತ್ತೆ? The solution after the hydrolysis
Option D,
looks
fourth one.
levorotatory. Yes. ಯಾಕೆ? ನೋಡಿ ಯಾವ ಆಪ್ಷನ್ ಇರ್ಬೋದು? This is a PYQ, very important NCERT given
Option
question.
D, fourth one.
Yes, very good. Levorotation of fructose is more than dextrorotation of glucose. Very good. So, yes. Sucrose, if you just take sucrose, it is dextrorotatory. ಆಯ್ತಾ. ನೀವು ಹೈಡ್ರೋಲೈಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Sucrose is made up of glucose plus fructose. When you hydrolyze, when you break down, it will give glucose and fructose. The glucose is dextrorotatory and fructose is levorotatory. But the amount of levorotation is very much. That is why this resulting solution will look as levorotatory. So dextro in the levo ತರ ಕಾಣ್ತಿದೆಯಲ್ಲ, ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ? invert, because invert ಆಗಿದೆ rotation. That is why it is called as invert sugar. Okay, that is the reason. Option D. Okay, fine. So we'll wind up this session at this point. We'll continue with this. Okay, thank you students. Bye bye.